that you got, one of them is your notes, one of them is your homework, and one of them is something called a BFF sheet, which doesn't mean anything to you right now, but it will soon. So you're gonna hang on to those, but right now it's our notes for after. And I am looking at my notes. Actually, it's not the very last page, it's the page before. It's right where we left off with the ball in the air problem. There's a little section down there that says 1.1. So we're gonna do those problems real quick, and then we'll get into on your notes, which for today is gonna be quite a bit of review, so I don't think it's gonna be too hard for you. All right, here we go. If you have the old notes, this is called a model. It's just a chart. It's a way of expressing numbers in a supposedly meaningful way. So it says, according to the numerical model, that's the chart here, what has been the trend in females joining the workforce since 1954? What do you think? Let's look at those numbers. Can you interpret that? What's the trend? Are they staying the same? What are they doing? Going up, right? Going up. You guys don't have any concept of this, but when I was growing up, when I was your age, there were very, very few moms that worked outside the home. Most of the moms stayed home. But now, how many of you have mothers who work outside the home? A lot of you do, right? A lot of you do. That has changed. The female employment is going up. In what 5-year interval did the percentage of women who were employed change the most? Okay, so these are all 5-year intervals. Can you see when it went up the most? I have to do a little bit of subtraction.
It's 279.
74 to 79?
Yeah.
Looks like it's going up. What is that? 4.9?
So.
Yeah, they're the biggest one. I think you're right. I think you're right. That is the biggest. That is the biggest increase. Okay. By the way, what's happening to the male employment during that same time?
Going down.
It's going down. Can you explain that? Do you have an idea about that?
Maybe some of the females are taking some of the males' jobs.
Okay, right, right. And traditionally, the kids have stayed home with a parent. Now, daycare is something that's really exploded in the last few years. I used daycare because I was a working mom. But when I was a kid, there was no daycare. The kids stayed home. So if moms are going to work, maybe dads are staying home. And also, in part of that time, there was the Vietnam War, and that took a lot of our men away, right? They couldn't work, they were in the service. Okay, all right, so here we go, comparing cakes. A bakery sells a 9x13 for the same price as an 8-inch diameter. If the round cake is twice the height, which option gives the most cake for the money? Okay, so let's pretend that tomorrow is your mom's birthday. And you're gonna go to the bakery and you're gonna buy a cake. They cost the same. You can get a rectangular cake, you know what I'm talking about? Just a regular rectangular cake, 1 layer. Or you can get a 2-layer round cake, same price. If you want to get the most cake for your money, How could we figure that out?
I'd weigh it.
So find the volume of it, the volume of it, how much cake is actually there. Well, this guy is a rectangle. I mean, this is way too big, but this is kind of its shape. It's just a rectangle. It's not that tall, obviously. How do we find the volume of that rectangular cake? Length times width times height.
Yeah, they give you.
Now, do I know how tall it is?
No.
No, but I do know that this one is twice as tall. So I'm gonna make up a number. How thick do you think that is? Maybe 2 inches? All right, we'll let that one be 2 inches high. Then this one is going to be 4 inches high, right? All right, so what is that? What's 9 times 13 times 2? How much cake do I get there? 9 times 13 times 2. 234 cubic inches of cake. All right, now what about this one? Now this one's round. This one's like a cylinder. How do I find, no, that's not a cylinder. How do I find the volume of a cylinder? Anybody know?
It's r squared times pi times the height.
Exactly. Very good. Pi r squared h. Now be careful. This h was a diameter, which means the radius is 4. So I have pi times 16 times 4. Remember, it was going to be twice as tall as this one. Mrs. Ford, how did you know that one was 2? I didn't. I made up a number. And that's okay as long as I make this number twice as much. Because remember, I'm just comparing, which is bigger. All right, so what's 16 times 4 times pi? That is 201.06 cubic inches. So if you're going down to the store to buy your mom a cake, and you're really all about getting the most cake for your money, which one are you gonna buy? The rectangle. The rectangle. Would there ever be a reason for you to buy the circular one? Yeah, you love your mom and that one's prettier. Maybe it's got pink flowers on it or something. So absolutely, you could still buy this one, but this would be the most economical, right? All right, that's it for the old notes. Let's get out the new ones. Here we go. We have 4 solved problems. And they are all reviewed, but some of us really need this review. So let's look at this guy. And let's talk about what are some options we have to solve this. What do you think? Quadratic formula? Absolutely. Is this a quadratic equation? Now be careful because A is 1, B is -4, and C is -1/3. Now, that's perfectly okay, but maybe you don't want to deal with the fractions. So what could we do before we get started so we don't have to do any arithmetic with the fractions? Get a common denominator, multiply everything by 3.
Yep.
So this would be 3x squared minus 12x minus 1. So I am just timesing everything by 3, including the 0, but of course that will change. Do you have to do that? Absolutely not. Why did I do it? Because I don't want to mess with the fraction under the radical. So here we go. negative b plus or minus the square root of. I'm using my calculator as necessary to help me with the arithmetic. So b squared minus 4 times a times c. Alright, what's under that radical?
This whole
Yeah.
third, 1/3, which is same as what it's on top of the
Okay, that's a great question. All right, let me come over here. So here's what we have. Right, so I am going to, get the denominators the same. And then I lose the denominators. So I'm left with 3x squared minus 12x minus 1. Okay, so I understand what you're saying. Instead of getting the common denominator, I multiplied this out. I got rid of it. So I times by 3 by 3 by 3. And the result's exactly the same. Okay? Because when you multiply this by 3, see how that cancels out? That's why I did it. Great question, though. Great question. All right, anybody got that figured out yet under there? What is 144, 156? Notice she added. Why did she add? She got 144 instead of 12. Why did she add them? Because she has a double negative. If you type that in on your calculator, it will add for you. I mean, it's okay, your calculator can do that. Can I cancel the 6 and the 12? No. How is the only way I could cancel the 6 and the 12? If I had a number here to cancel, right? It's gotta be all 3. So I'm gonna break down 156 and see what I get. I guess 2. Alright, I think I got it. Yeah. Okay. So how can I simplify this? 12 plus or minus what? 2 radical what? 39. These two have to stay inside. Now, I can cancel. Would you agree? So 2 goes in 6 times, 2 goes in 3 times, 2 goes in 1 time. So the answer to the question is 6 plus or minus 339 over 3. No more canceling. That's the end of the problem. Alrighty. How about this guy? Wake up. What do we want to do with this one? Do you think?
First, should you FOIL this?
Absolutely. We got a big mess here. We gotta clean this up. So this side's just gonna stay how it is, and I'm gonna first outside inside last here. So x squared minus 2x plus x minus 2. Okay, here's where I am. Now use your common sense. Don't just sit there and be quiet. Tell me, what makes sense to do now? Yeah, look over here. Don't you have a bunch of simplifying you can do over here? So again, I'll just leave this part alone for a second. And then over here, I have a -2, a +1, and a +5. So what is that? 4? You guys can do this. This is not hard. You can do this. All right, now what do you think? Start moving things around. Get everything over on one side. So I'm going to subtract an x squared. I'm going to subtract 4x. And I'm going to add a 2. So I subtracted x squared. Subtracted 4x. These don't cancel. They make -8. And added 2. And now everything's over on one side. Do you notice anything about these numbers here? They're all multiples of 2. So if you wanted to, could you divide the whole shebang by 2? Yes. You don't have to do that, but it makes your number smaller and more manageable. So we have x squared minus 4x plus 2. You will get the same answer if you move it this way. But if you simplify it, that radical you have at the end is going to be smaller. It's going to be easier to deal with. So I divided everything by 2 because I could. Does that factor? No. So we can do the quadratic formula again. Now that really is going to be a subtraction. So that's going to be 16 minus 8 is 8. Bless you. What about the square root of 8?
Break down the 2 and 2.
Thank you, Trey. How did he do that? I don't know, maybe he has that one memorized because we use it a lot. But right there it is, 2 root 2, right? Can that simplify? Yes, because look, can we take a 2 out of all of these? So if I do that, if I take a 2 out of everything, I'm going to be left with 2 plus or minus root 2. I'm not going to put over 1, but you can if you want. It's over 1. Okay? She says you guys are both good and she's not sure why your ticket's not showing up, and she'll fix it. All right, you ready for the next one? Try it on your own, you and your partner. See what you can do with letter C. What are your ideas? right, Stephanie, what'd you do first? Distributed. She said the first thing she did was distributed. I hope that's the first thing you all did. Right? That makes sense. You distribute. Okay? Chloe, what'd you do next after you got distributed?
Subtract the 5.
Yes, because we want to have our equation equal to 0. Now, we've already quadratic formula at least twice today. Can we quadratic formula this? But I don't know, did you notice anything about it? It actually factors. Now, I've said before, I'll say it again. The quadratic formula will always work, okay? Always. But factoring is going to be faster. So if you can see the factoring, absolutely go for it. If you can't, then it's okay to do the quadratic formula. The answer will be the same. All right, what do you think about that one? Everybody okay with that? If you did the quadratic formula, you would have to simplify your answer all the way down to this. This is the correct answer. So you would just keep going with your quadratic formula until you got there. Okay, well, one more on this page. What do you think about this one? Ethan, you have any ideas about this one, what you might do? I would definitely do some combining. Maybe add the 3x squared over to the other side. So I have 4x squared minus 5 equals 10.
Yep.
Is this a quadratic equation? Yes. You could do the quadratic formula with this one. You need to subtract this 10 over. And then be careful. A would be 4, but what would B be? 0. You don't have a B term, so you have to put zeros in for your B's. You can also do this one by adding the 15 over, dividing by 4. See where I'm going here? What am I going to do to finish this off? Have we ever done that before? Yeah. So it's just another option. If you want to do the quadratic formula every single time, that's okay. Do it right and simplify. But you can do it every time. What's my answer here going to be? X is going to be careful, plus or minus the square root of 15 over 2. Why is it over 2? Because the square root of 4 is 2. And when I square root both sides, I'm square rooting the whole fraction. Okay. All right, next page. Whoa, that was 1.1. 1.1 is due on Thursday. 1.1 homework. And if you look at the 1.1 homework, you will see that it is 4 problems like the 4 we just did. Okay? That is going to be due Thursday. All right, now we're in 1.2, which is a much bigger section. Now I'm looking at you because you were looking at the clock. You used to have a sign up there. It said time will pass. Will you do? All right, number 1. Which are functions? What do you remember about functions? What do you think? Which are functions? What? Is f a function? Actually, f is not a function. F is not a function because why? Can anybody tell me?
The vertical line.
Yes, if you drop in a vertical line, we have something called a vertical line test. Here's picture F, and that vertical line hits it twice. That can't be. Functions can't hit more than once. All right, so F is a no. All right, anybody have an idea about any of the rest of them?
C is yes.
C is a yes. C is a yes. C is a yes. Because if you drop down vertical lines, or sometimes they have you take your pencil like this and run it across it, you only hit the curve one time at most. Perfect. Alright, how about A?
Yeah.
A is a yes. What about B? No. B is a no. How about D? No. E, this is, it's kind of hard to tell. This is, E is just this part. E is just the red part. So is E a function?
Yes.
Yeah. Yeah. Okay. Everybody good? So if I give you a quiz and I say, is this a function? You'll be able to tell me yes or no. And explain why. It does pass the vertical line test, or it doesn't pass it. All right, now number 2. I need you to really pay attention here. So if you are trying to work on something else, please stop. This is a big, big deal, this idea of domain. When you have a question that says, find the domain, there are 2 basic rules that you have to follow. One of them says that whatever is under the radical, please write this down, whatever is under the radical is greater than or equal to 0. When you are finding the domain of something, and the domain is the possible x values, the x's that make the problem make sense. That's what domain is. When you are finding your domain, if you have a radical, whatever is under it has to be greater than or equal to 0. In other words, positive, not negative. And if you have a denominator, it cannot equal 0. These are your rules for domain. They're very simple, but you gotta know them. And if you know them, you'll get every domain question right. All right, so here we go. Problem A. Does problem A have a denominator? Nope. Does it have a radical? Nope. Therefore, it has no issues, and its domain is all real numbers. This means the whole number line. Why does A have all real numbers as its domain? Because it doesn't have a denominator and it doesn't have a radical. And those are the issues. Those are the red flags. Okay, so let's look at B. Is B gonna be all real numbers? No, because B has a radical. And what does our rule say? Our rule says that whatever is under the radical, so that would be x plus 5, whatever is under the radical has to be bigger than or equal to 0, which means x has to be bigger than or equal to -5, right? So what does that answer look like? It's not all real numbers, it's everything from -5 to infinity. And again, if you have trouble with that, just do a quick sketch. That will help you see that you're going from -5 to infinity. C. C does not have a radical, but it has a denominator. And what is our rule? The denominator, which is x plus 5, cannot be 0, which means x cannot be negative 5. All right, now I'm going to give you a break on this one. You can leave that like that, or you can write it as an interval, but writing it as an interval is hard because it's negative infinity to negative 5 and negative 5 to infinity. So instead of writing all that out, I think it's okay if you just say this. That means that x can be absolutely anything on the number line except negative 5. So if you want to write it officially, you can write it like this. This is the official way, but this is okay. All right, let's look at D. We are not going to be confused by D, you guys. Does D have a radical? No. Does it have a denominator? Yes. And what is our rule? Denominator cannot be 0. Which means x cannot be 1/4. And that's what you write down. That's it. That's all there is to it. E is a trick question. Go ahead and mark off E. That's a trick question. I'm not going to ever do that to you.
Where did the 1/4 come from?
I add 1 and divide by 4. So this is, you treat that just like an equals. So if you were going to solve that, you'd add 1 and divide by 4. That's what I do, even when it's in equals. Right, we'll cross this E off, and we're going to F. And the only reason we're crossing E off is because it's tricky. Its domain is actually all real numbers, but it has a denominator. It's a weird denominator. All right, how about F? Any thoughts on F? Is there a radical? Is there a denominator? Yeah. And what do we know about denominators? Whatever it is, it cannot be 0. So we're divided by 3, and x cannot be 0. So your domain is everything except 0 for problem F. All right, let's see how you're doing. Can you try G on your own? I'd love to hear some ideas. Gabby?
X plus 3, X minus 3.
Okay, so let's talk about that. You're on your way. That isn't exactly the answer, but you're on your way. She says, I have no radical, but I have a denominator. And I know that my denominator cannot be 0. She says, I've seen that before though. That's x plus 3, x minus 3. What does that tell me about x? X can't be negative 3, and x can't be 3. treat the not equal to just like an equation. So if you're gonna say x plus 3 is 0, x equals -3, then instead you're saying x plus 3 can't be 0, so x can't be -3. It's treated just like a regular equation. Alright, now we got a tough one. What makes this one tough? Problem H.
Because it has a radical.
It has a radical and a denominator, right? So both rules, both rules. What does our radical rule say? I erased it, hopefully you write it down. What does our radical rule say? Whatever is under the radical has to be bigger than or equal to 0, which means x has to be bigger than or equal to -5. What's the other part of the rule say? That's the radical rule. What's the other part say? Whatever is in the denominator, it cannot equal 0, which means x cannot equal 2. So again, I'm going to let you just write that, but let's look at what that really means. That means on my number line, I'm bigger than or equal to -5, but I can't be 2. So if I wrote that as an interval, which is always perfectly okay, it would be -5 to 2, and then 2 to infinity. But if you want to write it like this, I'm okay with that. There's a lot to keep track of.
So like on a test, we wouldn't have to do anything.
No. If it was just this, Gabby, I would want you to, but when you throw that in, that just makes it harder to deal with. All right, would you try the last two on your own? They are both radical problems. Try those. See if you can find the domain. I hope everybody started by writing this, because our rule says whatever is under the radical is greater than or equal to 0. That never changes. That's the rule. Now, when you solved this, I'm not sure what you did. How did you solve this? Subtract 2? That's what I would do. But you have to do that carefully, because if you subtracted 2, that leaves you with -x greater than or equal to -2. But then you're going to divide by -1, and what's going to happen? It's going to flip, and that is going to be what you end up with. Which on the number line looks like this, so -infinity to 2. What about this one? Where am I going to start? What's the first thing I'm going to write down? 3x plus 1 is greater than or equal to 0. And why am I writing that? Because that's the rule.
Wait, is it +1 or -1?
I have no idea. plus, but it could be a minus because it's right on that line, but I know it's a plus. All right, and we're gonna solve it. So 3x is greater than or equal to, we do get greater than or equal to negative 1/3. So thinking about what that looks like on the number line. Negative 1/3. All right, one more time. Mr. Blevins, give me a rule, one of the domain rules. What's one of the domain rules?
If it's a radical, it's greater than or equal.
Whatever is under the radical is greater than or equal to 0. Period, all the time. Kyle, what's the other domain rule?
If you have a denominator, it can't equal 0.
Exactly. Whatever the denominator is, it cannot equal 0. What if I have a problem that doesn't have a doesn't have a denominator and it doesn't have a radical? What's my domain? Oh, yes, negative infinity to infinity. The two things that are gonna mess up your domain are denominators and radicals. If you don't have those, then you're not messed up, okay? All right, was your hand up somewhere? Okay. All right, here we go, number 3. Does anybody know what an asymptote is? Can you tell me what an asymptote is? That word asymptote? It's a great word. No P is sounded. There's a P in the word, but it's not sound. You don't say the P. Asymptote. You don't know what it is? Okay, I will show you. We have shapes called hyperbolas, for example. Maybe you've seen one before, maybe you haven't. That's a hyperbola, and these lines are its asymptotes. I like to think of the asymptotes as like the girdle that holds the curve in. As we go out farther and farther, we're gonna be getting closer and closer and closer to that asymptote, but we never touch it. For our purposes, asymptotes will be lines, but they don't have to be. They can be any shape. But we're gonna have just lines as our asymptotes. Okay? You guys look like you need a cute story, so I'm gonna tell you a cute story. Way back in the old days, back in like 08, 09, something back there, the kids wanted for the math league shirt that year, the kids came up with this design, and the school wouldn't approve it. So they on their own had some made and wore them on the last day of school and gave me one. You know what it said? They were black with white writing, and on the front it had the, you know how you have the got milk thing with the big white question mark. It said got math with a big white question mark, and then on the back it said you bet your asymptotes. Isn't that cute? It was a cute shirt. I still have it. Okay, now we know what asymptotes are. We gotta figure out where they are in our picture. So here we go. It is very, very easy. Now, we are not graphing this whole curve now. We're gonna build our way up. We're gonna do vertical asymptotes, then we'll do horizontal asymptotes, then we'll do the zeros and intercepts and all that stuff, but one step at a time. Vertical asymptotes. Vertical asymptotes. And I'm gonna abbreviate. Vertical asymptotes. Denominator cannot equal 0. Oh my gosh, have we heard that before? That is part of domain. So what you're saying to me is x minus 1 cannot be 0, which means x cannot be 1. which means there is a vertical asymptote where x equals 1. A vertical asymptote is a cannot be. X cannot be 1. So I draw a dashed line in there, remember? I'm gonna get closer to it but not touch it. I can't touch it, because x can't be 1. So the equation of that line is x equals 1. But it's an asymptote because x can't be 1. So I have a dashed vertical line right down through where x is 1. That's it. That's all you're doing in this problem. You're finding the vertical asymptotes. Okay, so what about B? Where do you think the vertical asymptote is in B? Oh my gosh. Where do you think it is? Well, where do they come from? Vertical asymptotes come from the denominator cannot equal 0. So 3x cannot be 5 and x cannot be 5/3?
Yeah.
So that is your vertical asymptote. Now I have to sketch it. So 5/3 is like 1 and 2/3. Right here. Now, we're gonna learn how to graph that whole picture. Right now, the only thing we're doing is drawing in our vertical asymptotes. All right, can you try the next one? Emma, where'd you put your vertical asymptote? She said I put 1 at 2. How did you figure that out?
Because x cannot equal
So she said my denominator cannot be 0. So she added 4 and said x squared cannot be 4. And then maybe you square rooted. What do you have to remember when you square root? Plus or minus. So actually this picture, this would be interesting to sketch. This has 2 vertical asymptotes. You have a vertical asymptote at x equals 2, and you have another one at x equals -2. All right, one more problem. Let's do D. Would you see if you can find vertical asymptotes? I'll give you a hint. There's 2 of them. There's 2 of them for letter D. Why do you think I'm going to get 2 of them? Because the denominator can factor. I know some of you hate factoring, but oh my gosh, it's a skill you need. The denominator can factor. What does the denominator factor into? -5 plus 1. So x minus 5 can't be 0. X plus 1 can't be 0. So where are my vertical asymptotes? 5 and -1. So when you draw your picture, 1, 2, 3, 4. Vertical asymptote at 5. Vertical asymptote at negative 1. Now, I can tell by all the yarns and everything that you're on the edge of your seat, because you can't wait for the next problem, which is going to be something different, it's going to be something interesting, but you'll have to wait till next time. And homework due on Thursday.